$233. Yeah.
I don't have a pencil
You what?
I don't have a pencil.
It doesn't look like there's any back there. Here's one. Can we come get it? All right, today we start taking a look at patterns and multiplying with decimals. And we're going to move.
That sounds interesting.
Wow, and it sounds interesting and woohoo and wow. Yes, sir? We did. We did. And that's okay that you didn't know how to do it. Not a big deal. Okay? When we do new things on Math Minutes and you don't know how to do it, it's not a big deal. Okay? All right? Here we go. We're going to be taking a look at patterns. Then we're combining equal size rectangles from different fabric patterns to make a postage stamp quilt. Each rectangle has an area of 7/500 of a square inch, and she uses 1,000 rectangles to make the quilt. Okay? We want to know the area of the quilt. Okay? If you've ever attempted to make a quilt, it is very important that you are very precise, especially if you're using little pieces like this. Because if you mess it up and don't line it up properly, the whole thing will be a big mess at the end. It'll be out of shape. It'll look horrible if you were trying to make things look like this.
Have you done it?
Okay?
Have you ever tried to make a quilt before?
I've made several quilts, yes. I've made baby quilts for all of my grandkids.
Aww.
And here's how Mrs. Allen makes her quilts. She goes, oh, I like those colors. So I grab fabric off the shelf and I say, oh, I want so much material. And then I go home and I say, oh, this is what I want to do with it. And if I want everything to line up, it takes a lot of time because your corners all have to be exact and everything has to be measured precisely. Okay? Otherwise, it is not square, so when you go to put the back on the front, everything is whopper-jawed. Does that make sense? Okay? So, if you're not worried about that, you can always make it so that the corners don't have to line up and they can be offset and all that. Yes? What's a quilt? It's a blanket that a lot of times you just take different pieces of fabric and sew them together.
Or like tie them together.
Yep, you can tie them together. Okay? So a lot of times, like in the pioneer days, a lot of people made that was their blankets. But a lot of times they used scrap fabric. So like they might have used like worn out shirts. So they took the pieces of fabric off of the worn out clothing and just cut out squares from that and pieced it together to make their blankets. Okay? There's all kinds of quilts you can make today. People who make quilts, like a quilt like this, like you'd be really talented to do that. Because they're little tiny pieces, and you have to be very precise getting them together. Okay? All right? So, 7/500 of a square inch is pretty small. But you can see it turns out really pretty. And using all those different colors is really hard to get it and really precise as well. And the cutting out of the squares, I can't stand. But it makes it work correctly as well, as long as your pieces are exact. Okay, yes? Like the pieces that you're going to use, a lot of times are in squares that you sew together. So the squares have to be exact in size if you're wanting it to line up. And then when you sew them together, your seams have to be exactly the same. Because if they aren't, then the next piece you put on it, it's off. Okay? All right? So if we take a look at this, we're going to use a pattern to find the product here because we want to multiply each of these by 1,000. Okay? We're going to use 1,000 rectangles to make the foot. Okay? Well, because we've already worked with multiplying by 10, 100, and 1,000, we know that every time we multiply by 10, we move the decimal point 1 to the right. So if we multiply by 100, we're moving the decimal point 2 places to the right. And here is why you never say, I multiply by 10, I just add a 0. You notice I never let you say that this year? That we fill in with zeros if there's an opening. Do you remember me saying that over and over again? Okay? All right, we don't just add a 0. We move the decimal point 1 to the right when we multiply by 10. We move it to the right when we multiply by 100. And then if there's an opening, we fill in with a 0. Okay? So, if we multiply by 1, it's 75 hundredths. If we multiply that by 10, we multiply it by 10, it moved over 1 place, making it 7 5/10. There was nothing to fill in with a 0, right? So notice that business of just added 0 when we multiply by 10, that doesn't hold true, right? Okay? You multiply by 100, we move the decimal point over 2 places. Now when we multiply by 1,000, we move it over 3 places, and we have to fill in with 1 0 because there's an opening. Does that make sense? Okay? So the quilt will have an area of how many square inches? 750, so go ahead and fill in your 750 there. So as we multiply by increasing powers of 10, that means by 10, by 100, by 1,000. It increased by a power of 10. This is 10 to the first, this is 10 squared, this is 10 cubed, right? Remember that? Okay. So as you multiply by increasing powers of 10, how does the position of the decimal point change in the product? How did it change in the product? It kept going to the right. One more place to the right, yeah. Okay? So again, I can't emphasize enough that as we're multiplying by 10, 100, 1,000, and so on, powers of 10, we are not just filling in with zeros. Okay, we're not adding zeros. We are moving the decimal point over 1 place every time we do a power of 10. Okay? And then if there are openings, we are filling in with zeros. Okay? So as we take a look at this example, George is making a scale model of the Willis Tower in Chicago for a theater set. The height of the tower is 1,353 feet. If the model is 100th of the actual size of the building, how tall is the model? Okay? If it's 100th, it's going to be smaller, right? Okay? So 1 times that gives us the same. By which property? Identity property. 100th means that it's going to move 1 to the left. 1/10, I'm sorry, 1/10. 100th means it's going to move 2 to the left. So if it's here, it's going to move over, I'll get my marker up. If it's here, it's going to move 2 to the left, making it 13 53 hundredths. Does that make sense? Okay. So if we're multiplying by powers of 10, it's going right. If we're doing tenths, it's moving left. So tenths, hundredths, it's got to go left because it's getting smaller. Yes?
If you want to multiply it by different numbers, like we can multiply the same as a decimal.
You're picking up pretty quick here.
That's how it goes.
All right. So the model of the Willis Tower is going to be 13 53 hundredths feet tall. All right, let's do some estimating. Is it going to be shorter than this room, about as tall as this room, or taller than this room? How many think it's going to be shorter than this room? About as tall as this room? Taller than this room? How many taller than this room? Okay. All right. Okay, so number 2, as you multiply by decreasing powers of 10, how does the position of the decimal point change in the product? Decreasing powers of 10. How does the decimal point position change in the product? These are decreasing powers of 10. How does the decimal point change? Yeah, move to the left 1 position each time, right? So when you think about it, if we're multiplying by something, we always have more. If we have a tenth of something or a hundredth of something, we're getting less. Okay, so if we're getting more, we're going to go right. If we're getting less, we're going to go left. Less is left. Does that help you? Less is left. Does that help you? Okay?
I was thinking, like, plus and left both have LFB.
There you go. That's what I was hoping you would pick up on. Okay? All right? Does that make sense? Okay. Well, let's move on to our next page then and take a look at some more examples. All right. So if we go down here to A, let's go down here to A. If we have if we have 10 to the 0 power, well, 10 to the 0 power is equal to what? 1. 1. Okay. Remember that's equal to 1. So 1 times 4 and 78 hundredths is? 4 and 78 hundredths. Good. 10 to the first power tells us to move the decimal point how many places? Show me with your fingers. one place. So it's 47 and 8/10. 10 squared, or 10 to the second power, tells us to move the decimal point how many places? Show me with your fingers. 2, it's the second power because it's 10 times 10, right? So it's 478. You should be showing the loops. 10 cubed, or 10 to the third power, we would be doing what? How many places to the right? Show me. Show me, show me. Okay, total of 3. And now we have run out of digits, so we have to do what? Fill in with 1 0. There we go. That's the only time we had to fill in with a 0. Oh, good. Thanks.
Hey, Caleb, my guess is you'd learn more math if you actually paid attention and took notes in math instead of watching YouTube videos. Get your math book open. Start paying attention.
So part B, we have 38 times 1. 38 times 1 would be using what property? Identity, and 38 times 1 is what? 38 times 1/10. What happens to the decimal point there? 1 to the left. Excellent. Making it 3 and 8/10. 38 times 100. What happens to the decimal point there? Jonathan?
Moves 2 to the
2 to the left. Making it 38 hundredths. Do we have questions on this? Anybody? Anybody? You're going to show me loop-de-loop with the arrow at the end and tell me what's going on. Is that pretty simple?
Yeah.
Okay. Yes. Question? All right, let's take a look at this one. If we went from $3.25 to $325, what were we multiplying by? What would be our value for n? What would be our value for n? Pardon?
10 to the 4th.
10 to the 4th power, you said. And why 10 to the 4th power?
Because if it has 2 zeros, it has to be 2.
If it has 2 zeros, it has to be,
It has to move over.
it has to move over.
Yeah.
So it started out here. Oh, started out here. And you're saying it went here. Is that what you're saying? Yes. So you're saying it ended up here. 32,500 is what you're saying. Okay, so you don't like your answer now. You do not like 10 to the 4th power, so we will eliminate that answer. That's pretty easy to eliminate. It's gone. We'll pretend you didn't say it.
Okay.
Eduardo,
23rd power.
you're saying 10 to the 3rd power? Because you're saying it went from here to here and gave us 3,200.
Oh, no, I counted wrong.
What?
I counted wrong.
You don't like your answer either, we'll pretend you didn't say that. Zachary, you said what? I didn't hear you. 10 cubed, so you want this to be a 3?
No.
No?
Squared.
You want it to be squared, so you want it to be a 2?
Yeah.
Okay, 10. So, you wanted to have done this, making it this. Is that what you wanted?
Yeah.
Is that what it ended up being? Is that what this is?
No.
Is this $325?
Oh, yeah.
Is this $325? Are they the same?
Yeah.
Yes. Is this correct then?
That's what I
So this could be 10 squared or it could be 100. 100. Okay. Do you see how you figured that out though? I would expect to see something like that on your paper somewhere. Okay. How about number 6? How about number 6? What is n going to be? Oh, Bethany wants to try it again. Oh, she does. Go ahead.
Would it be 900? No, 895?
You think it's 895. All right. And we were multiplying by 1/10, so it had to come back one place to become 89 and 5/10. Is that what it became? Is she correct?
Yeah.
Yes, she redeemed herself. She was willing to stick her neck out again, and she was correct. Way to go, Finley. All right, but do we see how we show what we're doing here? Okay. How about number 7? Number 7. Number 7. You think I can do this? No? No?
I forgot what I was going to say.
Ezra? You think it's this?
Yes.
All right, so he thinks it's that. We're multiplying by 10 cubed. So we're going to go 1, 2, 3, making it 63,000. Is that what we ended up with? Nope. So couldn't we have started out with 63? Nope. So that one didn't work. Okay. Audra. She thinks it's 6,300.
No, 63.
She thinks it's 6,310.
Yeah.
1,
Yes.
2, 3, 6,300. Is that what we ended up with? No, that one didn't work either. So we're going to erase that one. 63 and 0 tenths. 1, 2, 3 gives us 63,000. Is that what we ended up with?
No.
No, it is not. Let's give it another shot. Zach, just can you tell me?
I was thinking, like, a 7.
You make me put my mask on. You're getting so close.
I was thinking, oh, no, like 0.
Let's try that one. We got to move 3 places. 1, 2, 3. We got an opening. Is that it?
Yes.
There we go, that is it. So 63 hundredths it is, 63 hundredths it is. All right, go down to 9 and answer those, please, quickly. Do you see that, how you check them out? Is it okay that it takes you several tries? Of course. Of course. Sometimes that's the way math is. So of course I'm seeing you do some things down there at the bottom, not just answering yes or no. You should be showing the arrows moving down there at the bottom. All right, tell me what we need to do for 9A. 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 Piper.
You have to move the decimal one, so it's the,
Which way, right or left?
right?
One to the right. Giving us 8 and 1/10. Yes or no?
No.
It's a no. That's what you would do to prove it, folks, right there. I see that proof. If there's no proof, I don't care if you put yes or no. I could get my grandson, who's 1 year old, to show you a yes or a no. Don't know that he knows what he's doing. No, he's not that smart. He doesn't know this stuff. None of my grandkids know this stuff yet. All right.
Someday you're going to be teaching them the same exact thing, and they're just going to be sitting there in your classroom watching.
Yeah, I doubt it. They're too young for that. All right. B, what would we do to prove that? What would we do to prove that? Adam, what would we do to prove B?
We would move the decimal
2 times to the right, making it 33. Is that a yes or no?
Yes.
Okay.
Yes.
C, what would we do to prove that one? Tyler.
We would move the decimal shift to the right.
Making it 5. Is that true or is that a yes or no?
Yes.
D, what would we do for that one? Adam?
We move the decimal 3 times.
We got an opening, making it 700. Is that a yes or no? And E, what would we do for that one? Ava. Right or left? Making it 3 8/10. Is that a yes or no?
No.
Are there questions? Anybody? Anybody? Okay, this is the proof you have to give me for all of them. Does that make sense? No proof? Not done. Does that make sense? Okay? All right, let's take a look at what you can do to prove all this on your own. On 237, you do not need to do number 12. You may cross 12 off.
Yay.
On 238, you're doing all. Oh, it's a lot. It'll take you all of 5 minutes to do some of it.
So
You
long.
know? What? I'm going to explain everything right now. I always do. Okay, today is Friday. Test tutor is due in today. If you don't have 10 out of 10 already, you may be checking that with me so you can keep doing it until you get 10 today. Get the point is due in today. Math writing is due in today. Make sure your rubric is attached to that on the side. That is being graded. Make sure that you have read through the rubric and that you are filling in all pieces of the rubric as you're doing your writing. Most of you are getting way better at that and are getting most, if not all, of the points, which is great to see. Okay? So make sure you're being very careful with that. All right? Test tutor gets point, math writing. That takes care of all of that. Assignment then would be next. All right? These come first, then assignment. IA Pink 10. IA Pink 10. If you did not get that signed off yesterday, that has got to be signed off today. It was an assignment yesterday if you didn't have it done. So you should already have it done now. Does that make sense? So if you didn't get it signed off yesterday, then when I get done talking, that would be something you would bring to me right away to get it signed off. Does that make sense? Kate, you look confused. What? Okay, then get it done right away and bring it to me. That would be right away. Okay? Some people wrote it down and saved it. I don't know how you did it, you know. But right away would be as soon as you can, okay? All right? Because that needs to be signed off on your folder. Okay? So, Pink IA, if you didn't have that done, that would be first. Then test tutor. Then these other things, which should have already been done and turned in, or ready to turn in. Then assignment. If you have all that done, then bring your assignment to me so I can look over that real quick. And then I will tell you what we can do from there. We have a half hour. My goal today is that you're not taking anything home over the weekend. It's going to be a gorgeous weekend. You're still to be busy doing your math in here. If you want more math to do, come see me. I suppose I can find stuff in my stash of stuff for you to do. Any questions from home? Caleb, I assume you're going to be doing some math now, not looking at YouTube videos. Is that correct? Get your math work turned in. And all of you understand what you're going to do for social studies. Is that correct? Starts at noon. You're meeting up with your social studies teacher, and you are joining in through your either math class Zoom or language Zoom, depending on who you have second period. Does that make sense? Hello out there?
Yeah.
Thank you. Thank you. Thank you for responding.
Yes.
Thank you. All right.